also they're saying that Comet 3I Atlas is unusual, unprecedented, exceptional. Well, guess what? So is the Earth. The Earth is the only rocky body of thousands and thousands and thousands that is made up of radioactive elements. The only one. 51% of our atmospheric heat comes from the radioactive stuff below our feet. It rhymes, so it's true. And what are all the other bodies out there? 1%, 2%, 3%. Except for Io, which is from tidal forces. It's being squished and pulled back and forth. Just like bending metal 3 times fast. It gets hot and snaps. That's Io. And then Neptune's got some chemical reaction going on. It's got more heat than it gets from the sun. But the Earth is the only one. The Earth is unusual, unprecedented, exceptional. The only one with a radioactive core and mantle.
The density of everything that lies on the surface is much lower than the core's average density. Scientists figured out that most of the Earth's mass is located towards the center of our planet. It's estimated that more than 80% of the core consists of one of the 10 most common elements in our galaxy, iron. But the iron on the Earth's surface is kind of limited. I know what you're wondering.
So if the core is 12.6, the density is 12.6 grams per cc, or 12,600 kilograms per cubic meter, and then the crust is 2.7, which is more like silicates, and aluminum's 2.5. Well, iron is only like 7.8. So what's in the core that makes it shoot up to 12.6, other than the fact all the gravity is making it more dense? It's a little bit of compression there, but still 7.8 going up to 12.6. What is in the core that's making it so dense?
And the last reason it's so hot is from the decay of radioactive elements. So why is this important? To come up with their findings, the temperature of the inner core is about 9,800 degrees, while the melting point of pure iron is about 2,800 degrees. Remember the P waves I told you about earlier? Well, these guys travel slower than they should while passing through the core. This shows that there must be some other element in there that we haven't figured out yet. Nickel is one of them.
So I've been told my whole life that the Earth is made of iron and nickel, and so are most of the meteors and asteroids. So now we got a core, a planet that's made of iron, nickel, and radioactive elements, which have the density of, well, like I said, aluminum's 2.5, which is the most abundant mineral in the crust. Iron is 7.8. I think nickel's a little higher than iron. Lead is a little, what is lead? What is lead? Lead's 11.2 or 3. Gold is 19.2 or 3. But why is this 12? We're not full of gold. We're full of lead. We're full of uranium, radioactive uranium, radioactive thorium, radioactive potassium. Our planet's made out of radioactive elements. In fact, 1%, almost 1% of our atmosphere is argon, the result of radioactive decay of potassium, radioactive potassium in our rocks or soils or fruits and vegetables. 1% of our atmosphere is like decayed bananas. So people have been wondering why this interstellar comet called 3I Atlas, oh here it is, 3I Atlas, it's been outgassing since way out here by, well beyond Mars's orbit. Can you read that? It's been outgassing for quite a while, and this is Jupiter's orbit right here. And most comets don't start outgassing until they go around the sun or somewhere inside of Earth's orbit, like in here. Well, no, wait. This is the Earth right here. Most comets don't start outgassing until they're kind of around here between Mars and Earth. But why is this one outgassing so soon? And why is the gas pointed towards the sun? Well, I figured it out. It's not a fuel tank. It's not a spaceship from another, alien race that's having to slow down and point its reverse thrusters towards the sun so it can slow down and get into orbit. That's not what's happening. What's happening is that this comet is actually made of iron and nickel like the Earth, but the Earth isn't made of just iron and nickel. It's made of radioactive elements, and it's molten lava. So it's already hot. If Earth didn't have a core and a mantle of molten lava, we'd have to be in Venus's orbit right here in order to be warm enough, because 51% of the Earth's heat comes from the core. And that makes everything boil a lot faster. That's like our atmosphere is 51% hotter. It's 100% hotter. It's twice as hot as it should be. And that is why 3I Atlas was outgassing so far away, because it's made of what the Earth is made out of: iron, nickel, and radioactive elements. Oh, and by the way, this is Jupiter's orbit right here, this line. Guess where the ice line is? Everything inside Jupiter's orbit, somewhere in here in the asteroid belt, is the ice line where the sun evaporates all water. So why wouldn't it be outgassing here? Why wouldn't it be? It makes no sense that most comets wait till they get into here, or here, or here, or here. This is Jupiter. Jupiter's moons are between 25% and 50% water. And if you go out further, things are like 95% water. Well, actually, it's ice out there. It's called the ice line. So that's another reason why it starts outgassing here. It's because it's inside the ice line, and it's made of radioactive elements like the Earth. And another oddity is, why is it outgassing towards the sun? Most comets are going faster than their gases, and they overfly the gases because they're coming around the sun, and the gases shoot out because the sun's light is pushing them out. But here the outgas is towards the sun. Well, what happens when you boil water? It shoots out of your tea kettle up away from gravity. Well, probably because it's lighter. But it shoots out through the hole. It shoots out sideways through the hole in your tea kettle. It doesn't shoot up because it's lighter. It shoots out because that's the direction that the gas is allowed to go out. Well, guess what? When your comet or asteroid has one side pointing at the sun, well, that side's going to get hot. And since it's already hot from the nuclear, the radioactivity, nuclear decay, that side's going to point at the sun, and the gases are going to come out in that direction. And since it's already moving so many tens of thousands of miles an hour, well, the gas is going to shoot out faster. So they're going to shoot out towards the sun and go out ahead of the comet. It's actually probably going out at not this way, because that's the way the comet's going, and not this way because that's directly at the sun. It's probably coming out at this angle, which is a combination of the two. And anyway, that's my prediction. Prove me right or wrong. We'll probably know by late October. By Halloween, we'll probably know that if it's outgassing radioactive elements, because this is going to be its closest approach to the sun. So it should be at its hottest, or maybe it'll be at its hottest a little bit after. So we'll know by Halloween if I'm right. Anyway, comment below, and don't forget to hit like and subscribe.